And welcome to Chapter 2, Section 5, the Periodic Table. Periodic, or periodicity, let's go with that. Periodicity is the tendency of, something to repeat periodically. Okay. That is to say, after a period of time, or a period of space, or a period of some other thing. In the case of the periodic table, a period is a row. Okay? One row is one period, and then things start to repeat. Specifically, chemical properties. They don't repeat exactly, but people noticed, well before they knew about the periodic table, they noticed that some elements behave very, very similarly to one another. They have very similar chemistries. So you have, for example, lithium, sodium, and potassium, or chlorine, chlorine, bromine, and iodine, for example, or copper, silver, and gold. They noticed that all of these things tended to repeat. I put these in groups of three. That was more or less an accident, but the fact is that one of the earliest people to notice periodicity also put them in groups of three, because that was more or less all he had to work with. Now, there were other attempts at organizing these things periodically than the periodic table. That is to say, the periodic table isn't the only effort people made. It's just the first one to catch on. The others were a little bit more esoteric, a little bit more strange. One person came up with his law of octaves, which got people to make fun of him, asked him to play music on his elements. But the fact is, he called it octaves because he noticed a pattern of repetition after every 8 elements. And we can explain that now today as well. In the end, the version that caught on was the periodic table in the 1880s with a shape that looks something like this.
Olha que coisa mais linda, mais cheia de graça, ela menina que vem e que passa. Doce balanço, caminho do mar.
Eventually, we added these 2 rows down here as well. There is a reason, just as there's a reason for groups of 3 and groups of 8 and so on. There's a reason why the periodic table has this funny shape, and that is something that we'll get to when we start discussing quantum mechanics, because they couldn't understand the shape of the periodic table until they got themselves to quantum mechanics about 50 years later. So that's when we'll save off explaining it. In the meantime, vocab. Okay, so a period is a row, and a group is a column. Okay. So one period, one row, one group, one column. Groups have similar chemistry. Now, they're not all exactly the same, but they're very, very similar to one another, such that the guy who first found the periodic table was able to predict, even though he arranged his by atomic mass, not by atomic number, the way we do, he was able to predict that 2 of the elements here in the middle should swap places. Even though one was heavier, it should be the one that came first, because it had the same properties as the stuff in this group, and the lighter one had the same properties as the stuff in this group. So he predicted that they should swap places, and eventually he was proven right. It would be another 20 or 30 years before protons were discovered, and that's what eventually confirmed that he knew what he was doing. He also predicted the existence, or I should say he predicted the properties of the element that would come in, I think it was germanium, there in the middle of the periodic table. In the end, the periodic table is the central organizing tool of chemistry. It's very, very, very useful, and it is deeply connected to some fundamental truths, like quantum mechanics. So, groups have similar chemistry, and these groups have names.
Moça do corpo dourado do sol de Ipanema, o seu balançado é mais que poema, é a coisa mais linda que eu já vi.
All right, so let's go ahead and start with the noble gases. They're among the last discovered, but because they don't react, which is why they're called noble gases. Nobles, they don't consult with the common types. Then, coming left from the noble gases, we have the halogens. That's the fluorine group. Here we have helium, and over here is hydrogen. And then underneath oxygen, the oxygen group is called the chalcogens. Similar to chalk. And then we have, underneath nitrogen, we have the pnictogens. That's a silent P on top of the pnictogens, because they are sort of similar to nitrogen. And then carbon's group doesn't really have a name because it changes a little bit too swiftly to really work easily for that. Then coming over here to the left, the first group, the first column in the periodic table, we have the alkali metals. Remember, alkalia. And that includes, potassium. And then right next to it, we have the alkaline earth metals. Notice things got a little bit squeezed there. And those are the groups that have names. After that, we have, this big group right here in the middle is the transition metals, because you're making the transition from the left side to the right side between those two tall blocks. Yeah, that's super awesome. And then we draw a dividing line down there. We have our non-metals is the group there in the upper right-hand corner, that triangle. And down here, we have the post-transition metals. And yes, none of the halogens are, but there's a chalcogen in the post-transition metals and a pnictogen, or a couple of pnictogens, I think, in the post-transition metals. Now, post-transition metal, PTM, whatever, that's not an official IUPAC designation. IUPAC, that's the International Union of Pure and Applied Chemistry, but it is a fairly common name, and that refers to the triangle in this tall block over here that is not the nonmetals. Everything that's not a nonmetal is a metal, so that's why they're called nonmetal. All right, and then this here, this group down here, that's different in that instead of naming groups, you're naming rows. Those are the lanthanides and the actinides, named for the first element in that row. Lanthanum for the top row and actinium for the bottom one. Really, these two rows, they would go in right here. The bottom two rows, and they would squeeze in between this group here, the alkali and alkaline earth metals, and the transition metals. But that would make the periodic table 32 columns long, and it starts to get really unwieldy then. So instead, we have it 18 and 14. 18 rows for the entire thing up top, and 14 rows for these two, or 14 columns for these two rows down at the bottom. And that works a lot better. The other thing, these are sometimes called the rare earth elements. So a lot of them are artificial. They don't occur in nature. I think it's like everything in here, in this row, is artificial. The lanthanides, are mostly natural, and the first few actinides are natural. But not uranium, but I think neptunium might be the last naturally occurring element that we know of. Don't quote me on that. I don't feel like looking it up right just this moment. All right, and those are all the names that you need to remember for the periodic table. That's not too much. That's period and group and alkali, alkaline earth, pnictogen, chalcogen, halogen, noble gas, transition metal, lanthanide, actinide, rare earth, post-transition metal, non-metals. Yeah, that'll be a breeze. You definitely won't have any trouble remembering all that. I'm kidding. You probably will. I suggest you make the effort to try and actually memorize them. Because we talk about groups all the time because they have that similar chemistry. You can talk about the alkali metals and the way they behave. You can talk about the alkaline earth metals and the way they behave, and that's different from the alkali metals and so on. So we often talk about groups, and you need to remember those. We also often talk about transition metals. We differentiate transition metals from post-transition metals, and both transition and post-transition metals are quite a bit different from the alkali and alkaline earth metals. And then, I almost forgot, because we so rarely talk about them. Here on that line, that pink line, we have the semi-metals, or metalloids. Exploring them is what got us our semiconductors. Everything that lies on a stair-step line, except for aluminum. Aluminum is a metal. But everything on a stair-step line starting at this corner here and going down right, down right, down right, everything that is on that line is a semi-metal. So it's boron and silicon and so on. Okay, and that will definitely do it for the names you have to remember. Understanding the periodic table is a lifetime of work, or at least, a couple of days. So now let's go ahead and hop over here and look at an actual periodic table. This is a very typical periodic table. It's ptable.com. All one word, ptable, pt-able. And it is very typical. It has all the information you're likely to need from a periodic table. It has, a symbol for the elements in question. It also has the names, which is not necessary, but nice. Above the symbol, you'll see a number. That's the atomic number, or the number of protons, which is also the number of electrons in the neutral atom. And then below it, you'll see a number, a decimal, like for boron over here, or for, say, helium, or any element. Like boron, element 5, is, it's that number underneath is 10.81. That is the atomic mass. Not the atomic mass number, the atomic mass. So let's go ahead and talk about that a little bit. The atomic mass number is not on the periodic table, and that is P plus N0. That's the number of protons and the number of neutrons. The atomic mass is a measurement. Okay, it's the average mass of the element. Okay. So elements come in different isotopes, and those isotopes will have different masses because they'll have different numbers of neutrons. And in nature, you'll find different percentages for the different isotopes. So the atomic mass is just the average that you find from looking at all those percentages. So boron with 10.81, it has two isotopes, so that's boron. So it has boron 10 and boron, 12. So boron 10 and boron 12. And so it's going to have a mass close to 10. This will have a mass close to 12. And the average of the two of them is 10.81. And so that is, that's the average. Because it's, you notice it's not 50-50. It's closer to boron 10 than it is to boron 12. Because there's slightly more boron 10. Okay, so it might be something like 55%, 45%. And some elements, I should say, have more than 2 isotopes, and some only have 1. And that is all reflected in the atomic mass written on the periodic table. Okay, they've already gone out and done the hard work of finding the averages and so on. So you don't have to. All you have to do is read the number directly off the periodic table. And that will be hugely important when we get into the mole. When we get into the mole, you will be using those numbers an awful lot. So definitely remember those. Now let's talk about the properties of the different things you'll find on the periodic table. Okay, first off, we have the metals. Okay, metals are shiny. They reflect light. They have a high melting point and boiling point. You have to raise the temperature quite high to get a metal to melt or to boil. See, they are ductile and malleable, which is to say you can draw it out into a wire, or you can, shape it with a hammer. And they conduct electricity and heat quite well. Metals are not good insulators, they are good conductors. And they are relatively hard. That is to say, you pick up a metal, you drop it on the ground, it's not going to squish or deform too easily. You have to hit it pretty hard. The reason you say it's ductile or malleable means that when you do hit it hard, it doesn't break. It's not brittle. Okay. Brittleness and hardness are not the same thing. All right, and over here we have our nonmetals, which are not shiny. They are soft. They are non-conductive. And they are not malleable. And they have fairly, sometimes very low melting and boiling points. In other words, nonmetals are the opposite of metals in all ways, which is kind of why they're called nonmetals. And then we have the semi-metals, or metalloids. And they are in between the metals and nonmetals in all things. And what exact properties they have, where they will lie, well, it's going to be, somewhere in between the high melting and boiling points of metals and low melting and boiling points of nonmetals. But, there's only a handful of the semi-metals. It's harder to come up with a trend for those, especially since there's only 1 or 2 semi-metals in every group. So they kind of, they're far more variable. They don't really have groups as much as the others do. And that's it for the periodic table. We will be spending a lot more time on it, but that won't be until we cover quantum mechanics. And that will be far more challenging for you. Until then, well, until next time, because we won't be starting with quantum mechanics. We'll be moving on to a different topic.